Hi guys, welcome back to a mathematics tutorial. So this is a continuation of our previous lesson. This is question number 13 on the finding derivatives of the trigonometric function. So now let's look at the 13th problem. So you notice that we're solving more problems, and the essence is because the more problems you solve on a particular topic in differentiation, the wider your understanding of the course. So this is question number 13, y equals to x raised to the power x cos of x plus x squared plus 1 divided by x squared minus 1. So if we are, if we are done solving this problem, then you can practice this one, because this is just similar to this. This x cos of x, this x, I just change this cos of x to sine of x. Now this, I just change this sign to minus, and then this, I change it to minus, and then I also replace it with plus. That's all. Just interchanging some of them. That's all. Now let's look at the first problem. So for this problem, we cannot use the power rule for this first term. That is to say, we bring this power down and we subtract 1 from this power. We cannot do that because the power is not a real number. The power is not a number. Like you have 2, you have 3, 4, and so forth. That's not the case here. The power is another function. So there's a combination of a trigonometric function and an algebraic function. So your major target should be how you can bring this power down. So if we just had a single term right here, we could say, okay, let's take the ln on both sides. But because we have two separate terms, so if we take the ln on both sides, the ln would not affect this term so that this power can drop. So what we need to do, we need to deal with them separately, this term and this term. So I can say, let the first term be some r equals to x raised to the power x cos of x. So if that is r, then I differentiate r. But first, take the ln on both sides. Ln of r is equals to the ln of x raised to the power x cos of x. So what happens? The ln of a raised to the power r is equals to r, the ln of a. So this representing a, this is now r. So we can bring this power down. So we have the ln of r is equals to x cos of x, the ln of x. So what do we do now? Differentiate both sides. Derivative of ln of r is 1 over r times the derivative of r, which is just r prime, equals, now here we have 3 different functions being multiplied by each other. So what we need to do is that we need to apply the product rule. So it doesn't matter how many factors are being expressed. The major thing is that you must differentiate them one at a time. So you can hold 2 factors and differentiate the other. So we can hold these 2 and differentiate x. The derivative of x is just 1. So just be cos of x, ln of x, plus. So we can now decide to hold x and ln of x and differentiate cos. We will now get negative sine of x, sine of x. So put this x and this ln of x. And then plus, we can hold now x and cos of x. So we hold a constant x, cos of x, and differentiate ln of x, which is now 1 all over x. So what do you observe? This x and this x cancel. So r prime now equals, now remember that this r can be multiplied by this numerator. So this will be r, because like we cross multiplying, almost like cross multiplying, right? So r times cos of x, ln of x, minus x, sine of x, ln of x, plus cos of x. So what do we need to do? We need to bring back the value for r. So r prime is now equal to x raised to the power x cos of x times cos of x, the ln of x, minus x, sine of x, the ln of x, plus cos of x. So this is not our answer. This is just the derivative of this first term. So now let's differentiate the second term. So we could call this p, let p equals to x squared plus 1 all over x squared minus 1. So what happens? P prime now, which is the derivative of p, we can use the quotient rule. So we hold on to the denominator x squared minus 1, and we differentiate the numerator. So the derivative of x squared is just 2x minus, that's the rule. The rule said we must put a minus sign between them. We hold the numerator x squared plus 1, and then we differentiate the denominator. So the derivative of x squared is just 2x again, all divided by this denominator, x squared minus 1 all squared. So let's erase this. So therefore we have p prime equals, so we can multiply this 2x by, or we just factor out 2x. This 2x is in both terms, so we can factor it out. What is left there is just x squared minus 1. And then also what is left here is x squared plus 1. But remember, this negative affects x squared and 1. So this and this gives us negative. This and this gives us negative as well. So what do you observe? This x squared cancel this x squared. So this x squared minus 1 all squared. So p prime now gives us minus 1 and minus 1 is minus 2 times this is minus 4x all over x squared minus 1 all squared. So now we've gotten we got our p and we differentiated p, we got p prime. We got our r first and we differentiated r, we got r prime. So now let's just put them within the equation. So finally we can have the derivative of y is just y prime. The derivative of this expression is what we got right here. So it's x raised to the power x cos of x times cos of x ln of x minus x sine of x ln of x plus cos of x. And then plus, what is this expression? The derivative of this is just minus, now this is minus 4x all over x squared minus 1. So this is actually our final answer for this particular problem. So thanks all so much for watching, and see you in our next lesson. Thank you. Please don't forget to subscribe. Thank you.